All right, welcome to this explainer. Today we're taking a serious deep dive into the extraordinary biological mechanics of how your brain physically reconstructs itself every single night. We so often think of sleep as just this blank space at the end of the day, a simple powering down phase. But we're going to look at sleep through the lens of pure neurobiology, exploring how your circadian biology, your autonomic nervous system, and your deep cellular energetics are all intimately connected. Because ultimately, this is what dictates your health span and your cognitive longevity.
Think about it, it's a massive evolutionary paradox, right? Why on earth would nature force us to lie, completely paralyzed, unconscious, and super vulnerable to predators for 8 hours every single day? Well, the answer lies in understanding that sleep isn't some passive state of rest. It's actually a high-stakes, highly active mechanism of metabolic survival. If you want to truly optimize your biology, you first have to master the architecture of your recovery, because every single second you're awake, you're racking up a biological debt that absolutely has to be repaid.
Let's kick things off with Section 1, the price of plasticity. So let's look at what's actually happening inside our brains when we're awake. Every moment you are conscious, your brain is actively adapting to the world around it. But that adaptation, it comes at a steep biological cost. Enter the synaptic homeostasis hypothesis. This concept reveals that our waking hours cause this massive synaptic saturation. Every time you learn a new fact, process a conversation, or really just exist and stay alert, you are physically strengthening synaptic connections. The problem is, you can't just keep strengthening them forever. Eventually, you run out of physical space and metabolic energy. Your mitochondrial energetics just can't sustain that endless neural expansion. Your brain physically requires the offline state of sleep to trim away the noise and restore its metabolic baseline. Literally, sleep is the metabolic price we pay for brain plasticity. While we're awake, learning all these regularities about our environment continuously drives up our cellular energy demands. It's kind of like turning up the volume on every single instrument in a massive orchestra. Eventually, everything just becomes incredibly loud, and your signal-to-noise ratio completely tanks. Your brain becomes saturated, wildly inefficient, and totally drained of energy. To restore any sense of clarity, the brain has no choice but to shut out the external world and initiate a hard internal reset. Which brings us to Section 2, the emotional braking system. You know that feeling when you haven't slept and every little thing sets you off? Well, long before you feel physical fatigue, your emotional regulation is the first thing to break down. In a well-rested brain, your medial prefrontal cortex, which basically acts as your emotional brakes, is strongly coupled to your amygdala. That gives you top-down, rational control. But sleep deprivation literally severs that connection. Instead, your amygdala couples up with the locus coeruleus. You are essentially handing the keys to your brain over to the autonomic fight-or-flight center, leaving your sympathetic nervous system completely uninhibited. You entirely lose your rational brakes. And get this, the numbers on this are absolutely staggering. It's a terrifying tipping point for our emotional resilience. Just one single night of sleep deprivation triggers a massive 60% amplification in amygdala reactivity when you're looking at emotionally negative stuff. 60%. Your brain becomes entirely hyper-reactive to perceived threats, so you start seeing danger and massive stress where a rested brain would just see a highly manageable, everyday situation.
So let's break down this cascade of symptoms, because this is where the daily consequences really hit home for all of us. When you're sleep deprived, you aren't just tired. You're actually operating in a highly volatile emotional state. We're talking heightened anxiety, a total inability to tolerate stress, and diminished executive control. But what's really wild is that it also drastically distorts your reward system. You start getting these exaggerated dopamine hits to immediate, cheap rewards, which is exactly why you crave junk food or mindlessly doom scroll on social media when you're tired, all while simultaneously suffering from degraded empathy and impaired impulse control. Your HPA axis becomes profoundly dysregulated, and you quite literally become a different, way less regulated version of yourself. Let's move right along to Section 3, the brain's deep wash.
Okay, let's pivot from the emotional side to the deeply physical restoration that happens in the deepest stages of sleep. This is where healthy aging is truly forged. We're talking about the glymphatic system, which is basically the brain's internal plumbing. And its mechanical sequence is highly state-dependent. It only kicks in when you hit deep, slow-wave sleep. At that precise moment, your central noradrenergic tone, which is your brain's wakefulness chemical, has to drop sharply. Only then do the floodgates open, allowing cerebrospinal fluid to actually wash through the brain tissue in this incredible convective flow. Specifically, this drop in noradrenergic tone leads to a mind-blowing physical change, a 60% expansion of the brain's interstitial space. The brain tissue literally shrinks back, which drastically reduces the physical resistance to fluid flow. Think of it like finally unkinking a garden hose. If you don't drop into this deep sleep state, the space stays compressed, the hose stays kinked, and nothing gets washed out.
And why does this matter so much for your long-term health? Well, as recent clinical trials show, this deep wash is physically flushing out Alzheimer's-linked proteins, like amyloid beta and tau, directly from the brain and into the bloodstream where your body can clear them away. This is a massive, game-changing breakthrough connecting sleep quality directly to cognitive longevity and dementia prevention. If you aren't getting deep sleep, you're basically allowing neurotoxic proteins to pile up night after night, fundamentally altering the entire trajectory of your cognitive lifespan.
Now let's look at what happens when this goes wrong in Section 4, the hyperarousal trap.
But what if your nervous system just flat out refuses to initiate this critical drop in arousal? Insomnia isn't just this frustrating inability to fall asleep. Fundamentally, it is rooted in a state of neurobiological hyperarousal. Wake-promoting neurotransmitters like norepinephrine and dopamine just stay elevated. That keeps your sympathetic nervous system highly engaged. Your brain desperately wants to enter deep sleep to clear out that toxic buildup, but the chemical environment of your nervous system is acting like a deadbolt on a locked door.
And this hyperarousal trap takes a few different, pretty destructive forms. Whether it's acute sleep restriction, just cutting your sleep short to meet a deadline, which immediately wrecks your processing speed and shatters your vigilance. Or maybe it's obstructive sleep apnea, which repeatedly starves the brain of oxygen through recurrent hypoxia, spiking your cortisol and directly driving up dementia risk. Or chronic insomnia, driven by an overactive orexin system that keeps your sympathetic nervous system completely revved up, keeping your blood pressure elevated and halting any chance of recovery. No matter the specific mechanism, disrupting this architecture is absolutely devastating to your biology.
Finally, we arrive at Section 5, the architecture of recovery.
So the million-dollar question, how do we biologically intervene without destroying the very sleep architecture we're trying to rescue? Well, true recovery is like a perfectly uninterrupted symphony. You have to move gracefully through N2 sleep spindles, down into the N3 slow wave sleep for that critical physical glymphatic wash we talked about, and then naturally up into REM sleep for emotional processing and memory consolidation. It's this highly orchestrated 90 to 110-minute cycle that has to repeat seamlessly over and over throughout the night. This is exactly why traditional approaches to sleep are so incredibly flawed. Conventional sleeping pills like benzodiazepines, they essentially just knock the brain out with a hammer by flooding it with GABA. They actively disrupt your vital slow wave and REM architecture. So yeah, you're unconscious, but you aren't actually biologically sleeping. Modern science, though, takes a scalpel instead of a hammer. Dual orexin receptor antagonists, or DORAs, uniquely target and quiet the brain's hyperactive wake signals by blocking orexin. They simply turn off the wake switch, allowing your natural sleep architecture to unfold exactly as evolution intended. It works hand in hand with your biology, rather than just brute force overriding it. And here's an incredible systemic benefit that researchers are really just now unpacking. By regulating this orexin system, we aren't just optimizing sleep. Orexin actually projects out to major neurotransmitter circuits all across the brain. So by turning down that excessive orexinergic drive, we directly stabilize the exact neurochemical circuits that are totally dysregulated in anxiety, depression, and mood disorders. We aren't just treating a bad night's sleep. We're dialing down the hyperarousal of an entirely dysregulated central nervous system. As we wrap up this explainer, I want you to completely reframe how you look at sleep. It is not a luxury. It is the ultimate biological necessity. Every single hour you are awake incurs a serious metabolic debt, and every night of deep sleep is the vital repayment of that debt. So I'll leave you with this final thought to consider for your own cognitive performance and long-term health span. Are you just closing your eyes at night and hoping for the best? Or are you actively giving your nervous system the biological permission it needs to truly recover?